to welcome our guest speaker, Alena Gavrilenko, a Lucy Mission Ambassador. Before we introduce Alena, here's Vivian or Kat, I'm not quite sure which one, with a few announcements.
All right, well, Kat got the exciting part out of the way. So I will share with you a couple of exciting upcoming things happening. If you have ever heard of the great astronomer Wilfred Buck, he's an indigenous Cree astronomer. And he has a documentary that just came out, and we'll be showing that for free as part of the ASP symposium. The show is on August 20th at actually, I'm not sure what time it is. I believe it's
5 p.m. Pacific.
Thank you. 5 p.m. Pacific, 8 p.m. Eastern. And it is a wonderful documentary, adult and has some adult themes. So I would say not for anyone under 13, but it is a great documentary. I encourage you to join us for that. And I think Kat's going to put that thank you in the chat. Let's see, we've been up to lots of things lately. We were at the Astronomical League convention and saw a lot of you there. It was really lovely to get to see each other in person again. I also gave a talk for the summer library program. Is called Color Our World, and it's a reading program that they have. And so we did a quick webinar about the Color Our Universe activity from the Night Sky Network and how to partner with libraries. So you're welcome to check that out. There's a free recording online, and I think Kat's going to put that also in the chat. Thank you very much. It's just called Color Our Universe, Hands-on Astronomy for Summer Reading Programs. And it's easy to access if you want to connect with your local library this summer. And I think, Kat, do you have anything else you want to share?
Last but not least, you all have been waiting for this, especially my more competitive clubs. The global stats are back on the NSN website. We had a time trying to get it all working again, but it is up to date, it is accurate, and I'm happy to report that we have surpassed 8.3 million visitors in the last almost 21 years of the network being live. So congratulations to you all. I'm super proud of everybody that's participated in this program for the last 2 decades.
All right, anything else? All right. Well, thank you, Kat. Thank you, Vivian. For those of you on Zoom, you can find the chat window and the Q&A window at the bottom edge of the Zoom window on your desktop. Feel free to greet each other in the chat window or to let us know if you're having any technical difficulties. You can also send us an email at nightskyinfo@astrosociety.org. And as Vivian mentioned, make sure that you select everyone so that we can see what you're putting in there. If you do have a question for our speaker, please put that into the Q&A window. That really helps us keep track and to know if we've answered your questions or not. And again, welcome to the July NASA Night Sky Network webinar. Alena Gavrilenko is from the American Public University, specializing in planetary science. She is a member of the APUS Analog Research Group and served as the research project lead for the SAM, Space Analog for the Moon and Mars mission, ARG-1S. And we've got all these acronyms here, and for the Integrated Lunar Martian Analog Habitat. Alina is alumna of the NASA La Space Mission Concept Academy and NASA La Space Proposal Writing and Evaluation Academy. Currently, she serves as a Lucy Mission Ambassador and enjoys sharing her passion for the Lucy mission and space exploration with the community. So please welcome Alena Gavrilenko. There we go. Looks great.
Hello, everyone, and thank you for giving me the opportunity to present during this meeting. I will present about the Lucy mission, which represents an epic journey to the fossils of our solar system. When most people think of the solar system, they think of the planets Mercury, Venus, Earth, and Mars in the inner solar system, and Jupiter, Saturn, Uranus, and Neptune in the outer solar system. One second. I have some technical issues. I'm unable to scroll my slides for some reason.
Hey, why don't
Let
you
me
exit out of that and
stop
restart
share.
the
Oh, yes.
There it worked.
Okay, let's start from beginning. Like, can you see my screen still? Like with the presentation?
No, I think you'll need to share again.
Oh, okay. Okay, sure. Now can you see it?
Wonderful.
Okay.
Thank you.
Yeah, let me try different way. Oh, sorry. Let me try share again. Can you see my screen?
Yes, although it's your edit mode.
Yeah. Can I do in the presentation in edit mode, since I don't know why it doesn't work in regular mode?
Oh, it worked when we tried it just a minute ago, didn't it?
Yeah, it didn't. I don't know why. So like, is it okay?
Maybe can you make it a lot smaller on the side and bottom, and we'll try and just make that full screen.
Okay, let me see if I can do it.
All right.
Yeah, maybe this is better.
Sounds great.
Yes. But our solar system is filled with more than just planets. Asteroids, which are rocky bodies that range from the size of cars to that of mountains, are found throughout our solar system. These asteroids are the leftovers of planet formation, preserving a record of what happened more than 4 billion years ago. They are, in many ways, the fossils of the early solar system. NASA's current mission, Lucy, is exploring a never-before-explored population of these remnants of our solar system. Lucy is named for a famous fossil of the human ancestor that was discovered in Ethiopia in 1974. Like the Lucy fossil, the mission will revolutionize our understanding of our origins. Lucy headed out beyond Mars, beyond the main asteroid belt, to two swarms of asteroids that orbit along with Jupiter. These two groups of asteroids are known as Jupiter's Trojan asteroids. No spacecraft has ever explored these important remnants of our early solar system until the Lucy mission. In order to understand why the Trojan asteroids are so scientifically interesting, we need to take a step backwards and talk about the basics of planet formation. Our solar system has 8 planets, 4 rocky planets in the inner part of the solar system, which are called terrestrial planets: Mercury, Venus, Earth, and Mars, and 4 giant planets in the outer solar system made of rock, ice, and gas: Jupiter, Saturn, Uranus, and Neptune. All of these planets began to form in a gas-rich disk that surrounded our newborn sun 4.5 billion years ago. Inside that disk, early asteroids formed. As these planetary building blocks hit each other, gravity allowed them to stick together. In this way, they grew into planets. The giant planets grew large enough that they could attract massive gas-rich atmospheres. What are the Trojan asteroids going to teach us? Some of these early asteroids survived, trapped in the Trojan asteroid region. So, when Lucy visits these asteroids, scientists will collect data to help understand some important questions. What rocky and icy materials lie beneath the massive atmospheres of the giant planets? Question number 2, how and where the giant planets formed, including if they moved around early in our solar system history? And question number 3, how materials needed for life, like water and organic material, moved around the solar system, and maybe how even they made their way to Earth. Lucy is going on a record-breaking journey to visit 8 Trojan asteroids and 1 main belt asteroid. For this trip, Lucy is going to travel almost 4 billion miles. Lucy is traveling at an average speed of around 40,000 miles per hour. So it will finish this road trip in less than 12 Earth years. In fact, although the Lucy mission is 12 years long, most of the scientific data will be collected in just few hours when the spacecraft is closest to each target. Now let's talk about the Lucy spacecraft. To go on a trip like this, the Lucy spacecraft needs large solar arrays. The solar panels are 23.5 feet wide and have a total collecting area of 550 square feet. The body of the spacecraft is similar in size to a convertible sports car. Here is the actual spacecraft at Lockheed Martin in Colorado, where final assembly and testing took place. Lucy launched from Cape Canaveral, Florida at 5:34 a.m. Eastern Time on October 16, 2021. We'll track its journey on this map showing the Earth and its orbit in blue. Let me see if I can move it a bit here. Jupiter and its orbit in gray, and Lucy and its way in red. Lucy's targets, asteroids, are shown in gold, and the main asteroid belt is located in gray region. Lucy will start out flying by the Earth twice. Because Lucy mission is launching on a small rocket, so it will start out in an orbit pretty close to that of Earth. The spacecraft will return and fly by the Earth a year later. Lucy will use this flyby to gain speed. This process is known as a gravity assist, helping the spacecraft get a bit more energy to head to more distant destinations. Despite the fact that Lucy will be visiting the Jupiter Trojan asteroids, it isn't actually going to Jupiter. Lucy used first Earth encounter, like first gravity assist, as an opportunity to test out the instruments and procedures, observing both the Earth and the Moon. Before its second Earth flyby, the spacecraft skims the inner edge of the main asteroid belt. There, the Lucy spacecraft will fly by a tiny asteroid that is only half a mile in size. The asteroid has been named Dinkinesh, the Ethiopian name of the Lucy fossil, which means "you are marvelous" in Amharic. When the first images of Dinkinesh came down, the team was excited to find that it had a satellite, which the team has named Selam. Since Dinkinesh is the Ethiopian name for the Lucy fossil, its satellite has been named in honor of another fossil that is sometimes called Lucy's baby. Here is higher resolution image of Dinkinesh and its satellite Selam, despite the fact that Dinkinesh was added as an engineering test. Mission scientists are learning a lot from these images. As the team continues to downlink data from the encounter, they were in for another surprise. The satellite Selam is a contact binary. It is actually two rocks that are touching each other. Lucy will only be able to fly by the asteroids, not orbit them or land on them. Lucy's three main science instruments are all related to cameras that have flown on previous missions. So the Lucy versions are named with a pseudo-French L in front of their names to show they are Lucy versions. L'Aurelie, L'Elf, and L'Tesse. In addition to these instruments, the T2CAM will allow the spacecraft to image the asteroids throughout the encounter and also do some science. And the high-gain antenna is both responsible for allowing us to communicate with the spacecraft and for doing radio science experiments, like determining the mass of the asteroids. Now let's talk about LaLaurie. Lucy's highest resolution camera, LaLaurie, takes black and white images of the asteroids. This is LaLaurie's view of Dinkinesh at closest approach. LaLaurie will show us the craters and also other geologic features on the surface of the Trojans in amazing details. Lucy's color camera, the RELF, is really two instruments in one. The MVIC camera has special filters that allows the team to create color. The images produced are generally false color, as the fillers were chosen to allow scientists to better understand the composition of the asteroids, especially what types of organic molecules are on the surface of the Trojan. The other part of LRELF is collage laser. This is a spectrometer, an instrument that spreads out light to allow scientists to see the unique signatures of the different ices that can occur on the surface. LITES is basically a remote thermal infrared thermometer. This instrument will allow Lucy to take the temperature of the Trojan asteroids remotely by measuring the amount of far infrared radiation that they emit. Since asteroids get all of their heat from the sun, their temperature will tell us how they store the sun's heat, and from there what their surfaces are like. After the second Earth flyby, the first flyby won't quite give Lucy enough speed to reach the Trojans, so Lucy will return 2 years later for a second Earth flyby and gravity assist. This will allow the spacecraft to head out to the Trojan asteroids that are ahead of Jupiter in its orbit. On its way to the Trojan asteroids, the spacecraft will do a quick flyby of the small main belt asteroid that the Lucy team named after one of the discoverers of the Lucy fossil, Donald Johanson. But this small asteroid is actually very interesting. It is one of the younger asteroids in the solar system, a fragment of a collision that happened 130 million years ago. The next flyby on this road trip and the first Trojan target is Eurybates, the largest survivor of one of the only known big collisions in the Trojan swarm. This means Eurybates will give us a chance to effectively look inside a Trojan asteroid. In 2020, the Lucy team discovered that Eurybates has a satellite. In this GIF, you can see how the satellite appears to the Hubble Space Telescope compared to a view where the satellite was too close to the primary asteroid to be visible. Just over a month later, Lucy will go by its smallest Trojan target, Polymele. This short interval between flybys is a challenge for the mission. During each flyby, the spacecraft will take around 1.25 gigabyte of data, which is about the same as an hour of HD streaming TV. To get the data down to Earth, the spacecraft has to use a high-gain antenna to send the data to big radio telescopes on Earth. Those telescopes known as Deep Space Network. It will take over a month to get all of the data down from the spacecraft. So Lucy will fly by Polymele before it has gotten all of the Eurybates data back to Earth. Recently, the Lucy team discovered that Polymele has a satellite. The team used a stellar occultation where the asteroid passes in front of the star to observe the shadow of this small satellite. Lucy will continue on and fly by Lucas. This very elongated and slowly rotating asteroid probably had an interesting history to give its shape and spin. Fourth Trojan asteroid, it's Lucy's reddest Trojan target. Lucy's last target in the leading Trojan swarm, Orus, is also the reddest target. Other outer solar system bodies get a reddish hue from complex organic molecules on their surfaces. Lucy will see if that is also a case for Orus. Lucy's orbit will then take the spacecraft away from the Trojan asteroids and back towards Earth. Lucy will be the first spacecraft to go out to the distance of Jupiter and return to near the Earth. The spacecraft will use the gravity of the Earth to do a small course correction, another gravity assist, and send Lucy on toward its final targets in the trailing Trojan swarm. Now let's talk about final targets. The grand finale of the Lucy mission is a pair of large, nearly equal-sized asteroids called Patroclus and Minotaurus. This pair is so close that if you stood on one, the other would appear to be 10 times the size of the full moon. This is probably a primordial binary pair of asteroids, and they orbit each other. And this pair of asteroids is left over from the very beginning of our solar system. A robotic spacecraft may be going on this epic road trip, but people are getting in there. People from all over the country and all over the world are responsible for making the Lucy mission possible. The Lucy team not only includes scientists and engineers, it also relies on project managers, financial experts, artists, students, and other people to make this mission successful. Lucy is training the next generation of NASA scientists and engineers. Join the Lucy mission. Lucy also is supporting a program to train the next generation of scientists and engineers. This program is for college students who are majoring in or interested in science and engineering related to exploration. The 12-week Les Space Academies run 3 times a year, spring, summer, and fall, and all the information is available. And while Lucy's main mission will be over in 2033, its journey won't be. After the final Trojan asteroid flyby, the spacecraft will actually be in a very stable orbit around the Sun. It will continue to travel between the Earth and the Trojan asteroids for hundreds of thousands, if not millions of years. And what I like the most about Lucy mission is the Lucy plaque. As Lucy will continue on this orbit for so long, it is not hard to imagine that someday future humans may find Lucy still traveling on this orbit. Therefore, in the same tradition as messages included on the first spacecraft to leave the solar system, NASA is including a plaque on the Lucy spacecraft. But while those carried messages for unknown spacefaring civilizations, this plaque is designed as a time capsule for our own descendants, carrying messages from some of the greatest thinkers of our day. Poet laureates, Nobel Prize winners in literature, and of course the Beatles, because of Beatles' song "Lucy in Sky." We hope that someday in the distant future, humans may return to this reminder of human ingenuity and humanity's desire to explore the solar system. Thank you for your attention, and for more information about the Lucy mission, you can visit those websites.
All right, thank you, Alina. We do have a couple of questions here, and so if anyone else has any questions, please pop them into the Q&A. So let's get starting. One question real quick. We could several people were interested in getting a copy of the slides, if that's available. If we could get those to upload so that people could use them in their local outreach where they live, that would be great. So another question, Jim asks, is there much risk to the Lucy probe from impact with micro asteroids and dust particles while it's traveling through the asteroids? Okay, unmute.
Alina, you're muted.
I'm not sure about if Lucy mission will be impacted by some particle in space. Like what about our International Space Station? When there is some danger of impact by space debris, the space station is usually moves to avoid the collision. I think for Lucy mission spacecraft, it might be programmed in the same way to avoid collisions, but like I will follow up with Lucy mission team and like ask for exact answer. And what about slides? I think most likely it is possible to get a copy and to get it posted for anyone to download, but I also will follow up with them. And maybe like in about a week, I will have some answer, and you can check updates like in YouTube description or there.
Great, thank you. So John asks, how far above or below Jupiter's orbital plane will Lucy encounter target objects?
I actually the Lucy spacecraft will not land, and it will kind of investigate asteroid targets from the distance during flybys, and I think the exact distance depends on those instruments, sensitivity, and yes, I also have to like ask, follow up with the team about the exact distance.
So I think that the question had more to do, not the specific distance away from the objects, but when Lucy's out encountering these asteroids, are they in the plane of the ecliptic along with Jupiter and the other planets, or are they above or below? And so, is Lucy going to be, I guess, significantly above, towards the North Pole, or below towards the South Pole, if you were to draw a line between the sun and Jupiter?
Oh, got it. I'm not sure about that. It's interesting question. I will follow up with the team to get more exact answer.
Okay, great. So Bill asks, how long will Lucy's systems continue to be able to communicate with Earth? And so I know that you mentioned that it's going to be in a stable orbit for a really long time, perhaps, longer than humans around. And so how long are we going to be able to continue communicating with the spacecraft?
I don't have like exact answer for that. But I think we can communicate with Lucy mission spacecraft using a deep space network, and it also depends, like because scientists were able to communicate with Martian rover, like even few years after the mission was complete, and the rover stopped communicating before because its solar panels got dust on it, and there was no more like energy. So maybe here will be a similar situation, and it will depend on how solar panels will work, and whether there will be some dust or damage. But I think it might be like a few years. Even after the mission, scientists will be able to track this spacecraft in stable orbit.
So we have a couple of questions here and about the power source on Lucy. And so it has solar panels, but are there batteries that the panels charge so that it will operate, continue to have a little bit higher energy budget, or is it completely with just the input from the solar panels?
I don't know. I will follow up with the team for a later answer.
And another question having to do with the distance. And so they're curious about whether Lucy is going to transmit its information while it's out at the asteroids, or is it going to wait until the closer flybys of Earth? And it looks like there's going to be a lot of those. And so will a lot of the transmission happen when it's closer to Earth?
So how it will happen? There will be a time delay, and for example, when Lucy will fly by Polymele, so basically the data from the asteroid will arrive to Earth when Lucy is already at like the next target because of the time delay.
Okay. And this is a question that a number of people had. So what are the key scientific questions that Lucy is aiming to answer about the Trojan asteroids?
Oh, the key scientific questions are about the origin of our solar system, because we can't we don't have instruments to get to the very core of our planets, and because of different processes inside our planets, some chemical elements, they transformed and they are no longer in the initial state of matter. And asteroids, they are time machine, and they still have on their surface and in their subsurface materials that were used to form planets in our solar system, including organic molecules. And investigation of asteroids will help us revolutionize our current theories of solar system evolution.
So we had a couple of questions, a couple different ones about that organic material, and both of them were interested in, what kinds of organic materials and, the composition of them, and whether or not these are related or similar to the precursors of life on Earth. So what's the relationship between that? And I guess part of the implication of that is was the Earth seeded by these early organic materials, and is there a relationship between that and the origin of life?
Yes. What about types of organic materials? I think yes, it's building blocks of life, like carbon, hydrogen, oxygen, water, like water ice, which might be on asteroids. And Lucy mission will also help us find out from where the life came. So whether it was formed inside our solar system, or whether it was planted from the outside in terms of those organic molecules and building blocks of life, precursors.
Okay, we're looking to see if anyone has any other questions here. So here is a question. One person asked, why are there Trojan asteroids? And so what's the origin story for the Trojan asteroids?
I don't remember exact answer for this question. But basically I think yes, I think it was in my presentation, and everything started from those building blocks of planets, and those blocks collided and formed planets of large mass, which was enough to attract atmospheres. But some asteroids, they weren't able to collide and weren't able to form round shape, and weren't able to become planets or protoplanets, and they stay in a shape and in composition in the same which was billion years ago. So they are basically like leftovers of planet formation, and so that's where they came from.
So we have another question that came up here. So William asked, how large is the team working on the Lucy mission, and where are most of them located?
As far as I know, the most of it is NASA, but there are also a lot of collaborations, including international collaborations. Yes, but I can ask ask the team about more exact answer.
Yeah. Do you know which NASA center is primarily responsible for the mission management?
I'm not sure like which exactly is responsible, but the launch was from Florida Center. Yeah. From Cape Canaveral, Florida.
Okay, great. Okay, let's see if we have any other questions that are coming up. And I think that, Kat, you are monitoring the chat on YouTube. Any good questions coming up there?
I posted some of them to our channel. One was, how long would Lucy, transmitting its information, from a distance, or will it have to wait when it orbits closer to Earth? What are the key scientific questions Lucy aims to answer about Trojan asteroids? Yeah, but it looks like there are no new questions in the chat.
All right. Well, thank you. And I don't see any new questions here in the Q&A from here. We did have a few comments here in the chat that Mary notes that the Trojan asteroids are the Lagrange points for Jupiter at L4 and L5, and that Goddard Space Flight Center is where mission operations is taking place. So
we did get one. We just got one, and this is more for Alena. What is the thing you are most interested in regarding Lucy and what it hopes to discover?
Yes, I'm most interested in astrobiology and in answers where the life came from, and also very inspiring and exciting, the Lucy plaque and the Beatles song. So maybe like people in thousands years from now will be able to listen to this song. Lucy, Lucy in the sky with brilliance, I think this one.
So we did have another question that came in. So where is Lucy right now?
It's let me
Well, approximately.
yes, let me Google it because it always moves.
I mean, if we're a couple million miles off, I think that we'd be okay. So
yes, Lucy mission recently, I think like about a month ago, flew past the asteroid Donald Johansen in the main asteroid belt, and now it is heading towards the Trojan asteroids.
Okay. Okay, we had another question that came up. I like this one, and this is from David. And David notes, are there any plans for a follow-up asteroid mission? And I know that there have been some other missions, and so maybe, thinking about a follow-up mission, but also some of the other complementary ones. How does Lucy complement some of the other asteroid missions that NASA has launched over the past few years?
This mission is special because it is going where not any other mission has gone before in terms of the distance, how far it is from the Earth. So it is going to bring some absolutely new data. So that's how it complements, it kind of expands our previous knowledge and shows the technological advancements compared to previous missions.
So I think it would have been interesting, and maybe this is something that you could find and that we would be happy to post, is that we've sort of had an oblique view of what the plaque looks like, but I don't remember seeing a zoomed in view of the plaque. I think that some of us would love to know what the plaque looks like. I don't remember seeing one that was just kind of a sideways view of it. Yeah. And so it'd be nice to get if you have access to a zoomed in view and that you could maybe provide us, or if you have a link to it, that would be great. Okay. Well, I'm not seeing too many other questions here. And so Vivian just put a link in to where you can see what the plaque looks like. So thank you, Vivian. And actually, Alina, if you wouldn't mind maybe stopping sharing, and then Vivian, maybe I can get you to pull that link up so that we can share that, and so we can see what it looks like.
Forgot to unmute. Yeah, let me share this. It's really beautiful. There's so many poets on here. Let me see if this is sharing. You can see my many millions of tabs open, but it looks something like this. Look at that. We've got Joy Hajaro, Carl Sagan, Yoko Ono. Wow. A lot of Beatles.
So
And Brian May and Martin Luther King Jr. So many. That's wonderful. Amanda Gorman's on there. Davis Sobel is on there as well. What a lovely plaque.
that really is.
I'm sure they're too small. They're almost too small for me to read on a big screen, but
Joy Harjo's on there?
Mhm.
That's great.
Lovely. Let's see. George Harrison says, when you've seen beyond yourself, then you may find peace of mind is waiting there.
I like that.
Yeah, I'll leave with the George Harrison quote. Can't hurt.
All right. Well, thank you very much, everyone, for joining us this evening. And I had just a couple of other, let's see if it'll pop up.
Thank you so much, Alena. It was great to have you.
Yeah. So that's all for tonight. And so join us for Cosmic Conversations on Tuesday, July 29th. And Kat will put the registration link in there again. Our next webinar is on Wednesday, August 6th, a little bit earlier in the month than usual, when we welcome back the NASA team for International Observe the Moon Night. And so we're looking forward to seeing the team again and hearing about changes for this year for International Observe the Moon Night. Thank you, Alina, for joining us this evening, and thank you everyone for tuning in. You can find this webinar along with many others on the Night Sky Network YouTube channel. So keep looking up, and we'll see you in a few weeks. Well, next week for Cosmic Conversations, and then the next webinar in a few weeks.
Good night, everyone.
Okay.
Before you all go, I did want to go ahead and put the survey in the chat.
Yeah, please let
And
us.
thank you so much, Alina, for joining us and coming and sharing the excitement of the Lucy mission with.
Thank you for letting me the opportunity to